Hello and welcome to CII's research webinar, Lifecycle Costing and the Triple Bottom Line, brought to you by the Facilities and Healthcare Sector Committee. We appreciate you taking the time to join us. I'm Mike Pappas, CII's Associate Director for Deployment. If you look in your GoToWebinar control panel, you'll see a gray bar labeled Questions. Feel free to enter your questions there and we'll address them after the presentation. Today, we're honored to have Dr. Robert Reese and graduate student Mansoor Sodagari from the University of Florida, and Professor Vivian Lofness and graduate student Susie Lee from Carnegie Mellon University. Robert, we're looking forward to what you have to share with us today.
Thank you, Mike. Thanks for the introduction. I just want to acknowledge the support of the Facilities and Healthcare Committee of the Construction Industry Institute for supporting this research. And today we're going to talk to you about life cycle costing and the triple bottom line. And our key message is, how do we incorporate financial, natural, and human capital in facility decision-making? We'll talk about the method that we've developed and the approach that we've put together for this study. We'll look at two case studies with some different aspects of each of those case studies in the presentation today. And finally, we'll talk about some of the takeaways and the report. The triple bottom line and life cycle costing have been established for a number of years. I'm talking about 25 years for life cycle cost standards development. One of the limitations of current facility decision-making is the first cost or short-term view of facility decision-making. So primarily looking at the initial cost, maybe some financing costs that are associated with the project, but in many cases not incorporating the life cycle of that facility. And that includes operational expenses, maintenance, repair costs, replacement of different components, and other costs that are associated with that facility over time. In addition to that financial capital, we're also talking about natural capital and human capital as a part of this research study. These are equally important in assessing facility performance for organizational value. So life cycle costing standards have been developed for about 25 years. This NIST life cycle costing manual is from 1995 and definitely sets up a structure for life cycle costing of facilities. We have initial costs, energy costs, operation and maintenance, and so on. The NIST manual also mentions non-monetary benefits and costs, but the implementation of that has been limited. So one of the goals of our research project was really to how do we establish those non-monetary benefits and costs as meaningful components of facility decision-making and analysis. So traditional financial return has been estimated by return on investment, which is just an annual benefit, right? And a first cost relationship, or years of payback, where we take the first cost investment and we divide it by annual benefits. Another popular assessment tool for financial decision-making of facilities is net present value, or NPV, where we do include a life view. We take future values, future benefits, future costs related to the facility, and discount those back to present value terms. And costs can be investment, maintenance, or replacement costs. And benefits can include things like income, future income, or other benefits that happen over the course of the facility. So we're going to talk about incorporating those as well and use those as some comparison between our approach for the triple bottom line and what we see traditionally in the facilities area. So when we look at these methods, we see that financial capital, right, is the most common, right? We see the present value life cycle cost of financial capital, the most common of the three triple bottom lines. We see an operation and maintenance, initial cost, and energy cost split over the life of the facility. When we look at including natural capital, in this case, this particular case study, we're looking at the benefits of carbon emissions, right? The value of carbon emissions. We see a small increase, but where we really see a large potential payoff is in the human capital, right? The salaries and benefits of the people that are using that facility over its life cycle. So these values are based on a 30-year study period and a 2% discount rate. So we're going to tap into that human capital and natural capital and show how those are going to improve the way that we choose high performance systems and components and make decisions in the facility. So I'm going to change over to my colleague, Vivian Lofness. We're just going to do a quick presenter change, and she'll continue the presentation from here. Vivian?
Got it. So hopefully you see my screen.
There we go.
Triple bottom line is a term that was coined by John Elkington and a few other economists back in the late 90s. Essentially to try to prompt the decision-making community, the business community, to remember more than just the financial capital decisions. Because when you look at life cycle costing, it typically focuses on things like energy savings and real estate space savings and water savings, things that hit you in the pocketbook and are measured in the same bookkeeping process. When you look at natural capital, there is a whole set of ideas that have been put forward as critical for the building sector and are actually beginning to show up in corporate social responsibility, CSR reporting, and in carbon footprinting, and a whole series of techniques that the leading facilities groups are beginning to adopt as necessary economic goals as well. And so we've decided to use the triple bottom line in order to make sure that we capture all three types of life cycle benefits. The toughest one is human capital, and most people I'm sure on this phone know that productivity and health are critical factors in why we build better buildings, but they don't necessarily know how would we quantify that, and we will try to show how some of that is quantified in the two case studies and see if we can make the case for why we should shift from just simplified calculations of cost benefit to a triple bottom line account. The way in which we've approached this project is to work with a series of clients in the CII facilities group and to develop some hypotheses, to establish cost differentials, to identify the benefits of those investments, and then use expert knowledge and research to actually quantify and put values on those benefits, because that's the tough part on productivity and health and even carbon. And from that, we can calculate return on investment and calculate a lifetime net present value. One thing you should know is that all of our work is done where the assumptions are completely obvious and cited, so that if any one of you begins to use the calculations, you can change the assumptions to suit what you fundamentally know or believe relative to your facilities or region. And then we make the case through written case studies. We were very privileged to begin to develop hypotheses with a number of the facilities committee members, University of Florida Shands Hospital System, Deloitte's EDGE project in Amsterdam, the Smithsonian Institution's National Museum of African American History and Culture, NASA's new headquarter project in Florida, and then we began work with the Department of State and with Kaiser to develop hypotheses of investments that were made in those projects that could in fact be cost justified through life cycle and triple bottom line cost. Because of the pandemic, we focused our entire year on 2 of those case studies and developed 3 hypotheses for each of them and built the economic arguments for each of them. And I will take one of those and then pass the baton back to Robert. Many of you may have had the privilege of visiting this museum before it was closed due to the pandemic in March. The National Museum of African American History and Culture is one of the Smithsonian museums on the Mall in Washington, D.C. What's important to note is that they invested very heavily in not just making a high-profile building, but a high-performance set of systems. And the arguments were made for why this building needed to have a high-performance box in a box in a box. I'll give more description of that. Why it needed to have a cutting-edge water collection and reuse system, and why it needed a cutting-edge HVAC system with dedicated outside air, heat recovery, and chilled beam technology for the offices. So let me talk a little bit about the hypothesis that we made. The investments in NMAC, and that's a shorthand since it's a mouthful to say National Museum of African American History and Culture every time. The investments in NMAC's museums, 4 layered thermal conditioning zones, which can be called a box within a box within a box, led to significant triple bottom line benefits, advances to the profit, to the financial capital, to the planet or the natural capital, and to the people, the human capital. The 4 nested zones are an airtight set of dry exhibit cases throughout the museum, so that their most tight thermal conditioning is in exhibit cases, set inside of exhibitor visitor zones, which are separated from the main circulation areas by automatic glass doors. So it's slightly looser, but still quite tight thermal conditioning zone. And then a very generous daylit circulation and congregation zone with no relative humidity control and a much wider band of thermal conditions. And that was set inside of a shading zone called the corona. So let me work this the other way. The corona is an exhibit itself. It has actually retail value. People are buying artifacts that are reminiscent of the corona to take home after they visit the National Museum of African American History and Culture. It is actually a cultural object. It was the architectural team working on this project were trying to be evocative both of historic African art and cultural icons, and also evocative of an industry that was very African American centric in steel and iron work. It also turns out it's a real energy saver. The variations in the corona densities were optimized by orientation, by south, east, north, and west to manage heat gain and glare with different levels of density on the orientations that had most problematic solar heat gain. The atrium, the next zone, is a public space that has significant cost premiums. In fact, if we just look at what you would need to circulate through the galleries, we estimated that there was almost a 7.72% increase in circulation area over what you would need. And at a cost of about $1,000 a square foot, which is what it costs to build museums of this caliber, it was a $31 million cost premium. In addition to that, the corona, which is a free-floating shading device outside of the high-performance facade, you could have left off that shading device and then upscaled the mechanical system to cope with the solar loads and the heat loss and heat gain loads and dealt with the glare issues. But the decision to invest in that corona was also a $10 million decision. So we actually have a first cost of $41 million, which we'll come back to, which we're going to try to cost justify. In addition to that, the exhibits themselves were isolated mechanically by automatic doors. So when you enter any one of the exhibit zones, you walk through a glass door, similar to walking in and out of a grocery store, that helps to secure the environmental conditions that surround the artifacts. It also provides security in the event of major public events, and I'll come back to that. And then the glass cases actually have desiccant units built into them, and that provides the tightest humidity and temperature control for the artifact preservation. Adding up all of those investments, those 4 layers of investments, we have a $41 million increase, or about $100 a square foot increase investment in creating the box in a box in a box. So what are the benefits? Well, the benefits of this box in a box, number one, we're seeing actually visitor numbers. Now, whether, we'll come back to whether that's just because it's the newest museum on the Smithsonian complex, or whether it's because it's a unique collection, or whether it's because of the actual artifact of the building. Surprisingly, the length of stay in this museum is twice every other museum on the mall. The energy savings are substantial. The artifacts have a much higher level of preservation. It is an event destination, so it is one of the highest and most loved destinations for hosting major public and private events. And it has high retail sales connected to the museum itself. So as we had started, the hypothesis is that the investments in this box in a box led to triple bottom line benefits. And we've made a list of the benefits on the right: financial capital benefits of energy and facility management savings, as well as events; the natural capital of carbon benefits associated with the energy savings; and the human capital of visitor numbers and visitor length of stay. So the financial capital benefits were 9% less heating energy, 2% less electric energy for cooling and ventilation, 4% less electricity for lighting energy, especially in the circulation zone, which is highly daylit, as well as 100 events a year at about $20,000 an event. So $2 million a year of revenue that is made possible by this nested set of zones. When you take that $41 million cost and you look at the benefits that accrue, we have about a 19 or a little under a 20-year payback period and an ROI of 5.1%. If we add the second bottom line, so for every kilowatt hour that this building saved, there is a commensurate carbon benefit, which in the US is roughly about 1 cent or 1.2 cents per kilowatt hour of carbon benefit. At about $50 per metric ton of carbon, it is absolutely valuable for us as a nation and for corporate sustainability reporting to show the carbon benefit of our energy savings. For every kilowatt hour that we saved in this building, there are pollution benefits of reducing SOx and NOx and particulates. And then for every kilowatt hour savings, there's also almost a penny of water savings. And so when we start to add those benefits, we're seeing something in the order of about $25,000 per year or $28,000 per year of benefit. It didn't take our ROI very far, but it did reduce the payback period by several months. And we're already at this point looking at a 30-year net present value benefit of about 10 or $11 million, so that this project, this investment in a box over 30 years is going to net $11 million for the federal sector. The third bottom line is always the toughest. How do we show that human benefit has value in the financial packaging? As I mentioned before, the most unique thing about this museum is that people who come here stay 4 to 6 hours. Whereas every other museum on the mall, the average is 2 to 3 hours of length of stay. And of course, one could argue the whole purpose of a museum, this is mission critical, is to get people to come and spend time. In addition to that, when people spend longer periods of time in a museum, they actually have a national average of a higher level of purchasing. So instead of $7 per person of purchase, we're looking at $12 of purchasing. We spent quite a bit of time in interviews with the whole host of design and operations and facilities teams to try to understand why is this museum have twice the length of stay of every other museum on the mall. And the answer was, well, it's partially because it's the newest building on the mall. And it's hard to get into. So everyone makes a pilgrimage to go see the newest building. And then because it was hard to get into, you really spend the time. Another is that it has the most powerful storyline on the mall. It actually, you want to hear the end of the story. It carries you through the history all the way of the early arrival of slaves into the United States and North America all the way through the 21st century. And you want to see the end of the story. We think it also has something to do with the fact that there is the freshest air in a museum. This is a very high ventilation rate museum with dedicated outside air systems, with a very sophisticated fan technology. And so we've assigned some of the length of stay to reduced fatigue, where because you're getting a lot of fresh air, your energy levels stay high. We also were told that the thermally, visually, acoustically, and spatially dynamic spaces, most museums are totally monochromatic. The temperatures are the same everywhere, the light levels are all artificial and the same everywhere. And this museum is dynamic, it's alive, something that is caused by a box in a box in a box design. And we've given 20% of the value of length of stay to that. We've also been told it's the best food on the mall, so people stay there for lunch and then they're rejuvenated and they stay longer after lunch, and so we've given 20% to that. So we had to make some assumptions here, and we've made these very overt so you can change those assumptions. The result of that 20% impact is almost a $1.8 million per year benefit to the mission of this museum. In addition to that, there was architecture-related retail sales at about $1.4 million a year. So we have $3.2 million of human benefit in this third bottom line. And all of a sudden, we've gone from what we had almost a 20-year payback to a 7.7-year payback. And the net present value over 30 years is $83 million. So the total story here is that $41 million of investment in a box resulted in a net present value of $83 million, paying back the $40 million and then accruing $83 million by a 30-year time frame. This is a wonderfully compelling story, only achieved through triple bottom line calculations. I'm going to much more quickly go through the other two hypotheses so I can pass this back. The water system in Namak is also very sophisticated. The 6 things that you don't usually see in other museums and certainly in many buildings, you don't see the extensive green roofs, not just on top of the buildings, but on top of all of the lower galleries. You do not see the extensive rainwater capture, the condensate capture from the HVAC system, the groundwater capture from the lawns, and storage and processing with a very large cistern to take all of that water, as well as $15,000 processing clean water tank where the gray water is feeding the toilet flushing, the irrigation, and the water features. This investment is at about $5.4 million. We're adding up all those 6 factors, or $13 a square foot. It is a non-trivial investment, but even the first bottom line benefits of water savings were non-trivial. They were able to eliminate 1.2 million gallons of potable water demand each year by capturing water on site and reusing it for all the end uses that I talked about, for landscaping, for toilets, and for water features. So that the financial capital savings alone give us about a 5% ROI and a 20-year payback, just at the financial level. When we add the natural capital, we were, through discovery, through interviewing the city of DC and a whole host of individuals, we found out that the mall on Washington floods once every 5 to 10 years with serious flooding, as you can see by the picture in the middle here. And that there is a proposal to build a $360 million pumping station in this district of the Federal Triangle and the National Mall in order to stop this flooding, which is catastrophic for a lot of buildings and for what they house. If every building on the mall and in the Federal Triangle in this region did the level of investment that NMOC had put in, this $5 million additional investment, they would not need this $360 million pumping station. The level of contribution of NMOC to reducing this is measurable. And it would take, of course, a whole suite of 30 or so buildings to be able to displace the need. But we can take those $360 million and divide by all the buildings and figure out what the value is. So we put a value of avoided damage to the Capitol Mall at about $120,000 per year. And what you'll notice here is we've gone from a 20-year payback to a 13-year payback because of the natural capital. This is not in the pockets of the Smithsonian's operating budget, but it is in the pockets of Washington, D.C. and the natural capital that we share. The third bottom line is, again, the toughest. What is the value to the occupants and humans of this building? And these two water features, the water feature that's at the entry with a series of fountains that add evaporative cooling for the people who are waiting to enter the museum, and the contemplation court, which is in the middle of the museum, an incredibly restful sort of 10-minute break between the lower galleries and the upper galleries, heavily used by all the people who come here. We've put a value on that because we think it's contributed to length of stay. And the consequence of all three of those is that we're now looking at a 6.4-year cumulative payback. So we've added these paybacks. It's gotten lower and lower. The ROI went from 5% to 7% to 16% by the third bottom line. And the net present value is now at almost $10 million. And the last hypothesis, I will just give you the bottom line. We don't have time. There's a whole report behind this. They invested in fan wall technology, air side economizer, enthalpy recovery, electronic filtration, water side economizer, dedicated outside air for the office systems, and chill beam for the office spaces, roughly a $5.4 million investment. And when we did our first bottom line, we saw an 18-year payback on energy. On the second bottom line, it became a 14-year payback when we added the carbon footprint of those savings, and then by the third bottom line, a 2-year payback, so that it became a net present value of $40 million. We think triple bottom line accounting is very effective at telling this story. And I will now pass this back to Robert. Oops, well, change presenter. Oh gosh, it lists everybody here. You guys are all presenters. Robert, where are you?
I'm here.
Yeah, really. Oh, here, I got it. Woo. Okay.
Okay, thanks, Vivian. And so we're just getting the screen loaded up here, and we'll be ready to go. And thanks, Vivian. That's a great review of a really exciting project. And we have a second case study that's also a very exciting project. This is headquarters building for NASA. It's called the Central Campus Headquarters Building, and it's at the Kennedy Space Center in Florida. This project is unique. It presents some unique opportunities to look at triple bottom line accounting and triple bottom line decision making. The three hypotheses that we covered for this case study is the first one is one that I think a lot of organizations have questions on, or similar questions. And that question is, should I remove my aging facilities and consolidate some of those into a high performance facility? What are the benefits that we might get from going down that path? When should we start to look at either updating or replacing existing facilities? And then the second is high performance building components. So this is focused just on the headquarters building itself. And then as part of this project, the NASA installed a photovoltaic panel array that's generating carbon-free energy for the facility. So we'll take a look at how that fits into the triple bottom line. But when the KSC headquarters buildings, really consolidating those facilities from the time that the Space Center was established on the coast of Florida, It has a campus concept. There's a number of buildings that are spread throughout the Kennedy Space Center. The site for the headquarters building is about 5 acres. It's a 7-story, 200,000 square foot approximately building with about 500 employees. It does provide some additional shared services to the campus and some shops as well. We'll be looking, the case study that we're going to talk about here, I'll focus in on the life cycle cost analysis, and we're using a 30-year study period and a 2% discount rate for that. So why would this question come up in the first instance, right? Why should we consolidate our facilities? And when maintenance and operations are getting more and more costly on aging facilities, we have inefficient energy systems. We're using a lot of electricity for cooling and for operating, for lighting. We may be using natural gas, for example, for heating. We don't have optimal work environments for the workforce. Right? We don't have the appropriate space utilization, that could be improved and optimized in a new facility. We also have, obviously in this case, the image of NASA, right, is on display with the facilities that it owns and operates. And lastly, we're taking what was formerly low-rise spread out facilities that occupy a large footprint on the campus and consolidating them into a single building. So we're talking about facilities from the 1960s. They're about 50 years old, and they're getting towards the end of their life cycle. So a decision has to be made on whether or not to, incorporate those and create a new headquarters building. And that was the decision that was made, was to do a phase 1 is what you see in this bottom part of the slide. And in the future, a phase 2 of new headquarters buildings that consolidate facilities. So what are the issues here? Is increasing first cost, right? If I continue with my existing facilities, I just have to operate, maintain, replace, and not have a large first cost outlay in order to design, construct a new facility and demolish the existing facilities. We have moving costs and activation costs that we have to consider, and startup costs, right? So all of those relate or sum up to a significant first cost investment of about $87 million in the new facility. The question is, will it pay off, right? And where are the opportunities, right? So the financial capital, we're looking at energy use, operation and maintenance. How do we spend our budgets on operation and maintenance versus capital improvements, right? Versus new facilities and capital improvements. So that's really the trade-off that we're going to illustrate in this case study. So we have the status quo, which is the continue operations of existing facilities, continue to maintain those, continue to run what are really are aging and really subpar in very many aspects. So if we look at the trade-offs, we can estimate for example, what the energy consumption will be in the new facility. Look at what it is in the existing facilities that we're going to potentially remove, and then look at the annual operation and maintenance and calculate, right, that present value over its life cycle. So for the next 30 years, if we continue to use those existing facilities, we're going to increase the life cycle cost of the status quo over that time, compared to investing in a new facility, in a new headquarters facility. So that first bottom line results in savings in electricity, kilowatt hours, and therms of natural gas. We can annualize those over the 30-year life cycle, comes out to about $4 million per year, and a cost per square foot. And we're looking at a financial return on investment of about 4.5% and a payback period of 23 years. But if we look at the life cycle cost of the two options, the new headquarters facility, including the first cost, is about $141 million. If we look at continuing the operation of the status quo, we're looking at over $200 million. So the reduction in life cycle cost for constructing a new facility is about $63.5 million. So for that investment, we're seeing a long-term savings in life cycle cost over the life cycle of the facility. But what if we also include the natural capital savings? So we're looking at the carbon emissions in this case related to the electricity use and the natural gas use in both the status quo facility as well as in the projected energy use in the new headquarters. So we have a reduction in electricity consumption. If we look at the annual difference, we also have a reduction in natural gas consumption that results in an overall difference in carbon emissions over the life cycle of the facility. So annually, a reduction in about 9,000 tons of carbon dioxide emissions. That relates to an annual carbon emissions reduction benefit, right? If we look at the cost of carbon emissions of about $250,000. So we incorporate that into our triple bottom line assessment that improves our ROI to 4.7%, reduces our payback period to about 21 years, and increases the difference in the life cycle cost. So now we're up to about $79 million difference between the life cycle cost of the new facility, the Kennedy Space Center headquarters, and continuing with our status quo. So the third bottom line, the human capital savings, we're also introducing that aspect into our assessment. So in this case, we're specifically looking at the occupants of the building, right? We talk about the improved conditions, the improved space utilization. Those things translate into improved productivity of the workforce and also the health of the workforce. And we have fewer absentee days. We have less sick building syndrome cases, less effect on the workforce. Overall, that has significant value, as we showed in our earlier slide and as Vivian showed for Namaque as well. So we're looking at productivity increases. We're looking at what that value is on an annual basis and also in a life cycle cost basis over the 30-year life cycle. So if we look at that benefit, we see a difference in the 30-year life cycle cost between the new headquarters building and operating the existing buildings of over $100 million. So that benefit can be realized by investing that $87 million in the design, construction, and startup of a new facility. So cumulatively, if we look at all of those bottom lines, we're seeing a significant savings and a significant benefit to the Kennedy Space Center, both in terms of the financial costs, in terms of the environmental benefits, and in terms of the effect on the workforce, the productivity and health of the workforce. All of those are extremely important. All of those have value, and that's what we've been showing with our triple bottom line approach to the life cycle cost assessment of these facilities. The second hypothesis we take a look at is just the building itself, right? So now we're looking at comparing this new headquarters building to the another facility on the Kennedy Space Center campus. We're taking data from both of those facilities and looking at the impact. How is this building performing relative to similar buildings on the Kennedy Space Center complex? So we worked with the Kennedy Space Center staff in order to get data on the performance of existing facilities, and we're looking at the high performance building components of just that new headquarters building. What impact does it have on energy costs? What impact does it have on carbon footprint? What impact does it have on the occupants, and how do we understand that? So our baseline comparison building that we identified on campus is a similar building, 5-story, 190,000 square foot, about 900 office spaces, as well as a conference center. So we're looking at the increased cost of the high performance components of the headquarters building. And some of those are in the enclosure, right? There's some glazing and shading components that are in the new headquarters building. We're looking at a high efficiency lighting system, as well as a high efficiency HVAC system that consists of chill beams that provide a much higher level of occupant comfort. So we're looking at that investment in the headquarters building relative to the benefits. So we see financial capital benefits. So we have energy savings, lighting energy savings, as well as conditioning energy savings. As I said, we have lower carbon footprint, and then we have improved capital, human capital benefits in terms of the occupants and satisfaction, productivity, lower absenteeism related to the improved thermal comfort of these high performance systems. So I'm just going to jump to the bottom line summary here so that we can conclude our presentation and get to some questions and discussion. When we look at the cumulative benefits, we really see the net present value, the 30-year net present value analysis, showing a positive net present value when all of these three triple bottom line aspects are considered. We have a 7-year payback for that cumulative bottom line, and a 15% return on investment for these investments in these high performance components. Last thing, I'll just touch on this briefly. The part of the project was installing a photovoltaic array that produces electricity that offsets the electricity consumption of the headquarters building. Obviously, this has impacts on the cost of operating the facility in electricity, and also reduces the carbon footprint. So we're looking at two of the bottom lines here, the environmental and the financial. There are some human benefits, some occupant benefits that we could consider, and that's potentially the additional benefits in air quality due to the no emission photovoltaic panels. So when we looked at this, we're looking at the initial cost of the system, right? That's a first cost increase from just purchasing electricity from the utility. And we're looking at the financial benefit over time, right? We have energy costs, we have electricity energy costs from a utility over time, or we have an investment in a photovoltaic system that requires some operation and maintenance costs, some replacement and repair costs, but overall, may show benefit compared to utility. And then finally, the environmental benefit with the reduced carbon footprint. So the financial benefit does show a positive net present value of about $4.6 million over the 30-year study period, and a payback of about 26 years, ROI of about 4%. If we add in the environmental, we reduce that a little bit more to $5.8 million of net present value over the 30-year life, shortening of the payback to 23 years and improving the ROI to 4.3%. As I said, we haven't addressed the, the human dimension here, but that's something that we could also look at in the future. So I just want to take a moment here really to acknowledge the team that was working on this research project, and specifically the research team from the Facilities Healthcare Committee, but also the individuals that we worked with on both the NASA case study as well as the NMAC project in Washington, D.C. And Brenda Sanchez was the chair of our research team, so I'd like to also acknowledge her work for the research team. This has been a significant team effort. So lastly, just to wrap up before we go to questions, we strongly believe that this is the correct approach to evaluate high performance facilities. We're looking at the full cost of ownership, and that includes the breadth of those capital impacts as well as the life cycle of those facilities. Considering those aspects will, when investing in a high performance facility, will allow you to identify the benefits for those facilities, and in the end, turn into optimizing the value to the organization. So our report will describe the life cycle cost triple bottom line methodology, and also include the case studies, the 6 case studies that we covered in the 2 facilities that we looked at for this project, the Smithsonian Museum, as well as the NASA headquarters. So we're looking to wrap that up shortly and release that through the Construction Industry Institute. So that concludes our presentation, and I'll return it back to Mike, and if he wants to sort of moderate any questions that have come up. I see some of the chat may have some questions in it. Mike?
Yeah, thanks, Robert. Thanks, Vivian. Appreciate the great presentation. We do have some questions, and so let's start with NMAC. What did the initial business case look like? What did it project as triple bottom line benefits?
So I don't think, and I'm not sure if I know there's some NMAC people on this call. I don't think we ever were given any kind of cost benefit analysis that targeted these systems as a whole. There were definitely some cost benefit trade-off discussions that occurred as systems were put forward. So the fan wall technology versus a series of large air handlers. There were certainly discussions that occurred. Keeping in mind that we built this case study probably 4 years after NMAC opened, which means that it could be as much as 10 years after the moment when those engineering analyses were and design trade-offs were discussed. There was surprisingly not a lot of life cycle records or reports that we could build on. Interviewing became the most critical path, and we interviewed over 30 individuals. Amazing expertise was working on this project with an incredible amount of pride and coordinated debate. So in answer to your question, there was not a written report saying, here's our life cycle costing. There were certainly individual debates as systems and components were traded off.
Okay, thanks. Somebody asked, are the slides available for further review? And typically what we'll do, thanks. Typically what we'll do is if you go to construction-institute.org/blog by tomorrow, or for sure, yeah, by tomorrow, we'll have the recording of the webinar up there and the slides as well for people to take a look at. There are a couple of comments here about the NMAC being an amazing place, you know, people that obviously have been there. I love its thermal conditions, and the powerful description of the African American story is one of the comments. A couple questions on NASA. You indicated the buildings had a 50-year service life. What is the expected, somebody did a new question and my screen jumped. What is the expected or planned service for the buildings now, for the new building?
So the study is the study that we used was 30 years. It's between 30 and 40 years. And I think, there's an interesting debate about service life, if I could just go into that a little bit, because, we see buildings that, obviously have significant value that will be maintained for much longer than 30 or 40 years. We're not considering demolishing any of the Smithsonian museums anytime soon, right? So there is a trade-off, not a trade-off, but a recognition that if we value buildings and we invest in buildings, we will maintain those high-quality buildings over time. And they have cultural value, they have significance, but they're also functionally, operational, either flexible or they justify the investments in upgrading components and upgrading those facilities. So how to exactly, sort of set that study period, I think is a question that organizations need to look at on an individual basis. It's a really good question, as to how long will, University of Florida maintain its buildings. And so far, it's been over 100 years and they're still maintaining those buildings, and those buildings are still functional. And that organization sees long-term value in the building. So I think it's a good question for an organization to ask, and should figure into the analysis itself. So thanks for the question.
Thanks, Robert. Next question, is there a white paper, calculation templates, or other resources available regarding the triple bottom line approach? Or is that what your research is going to produce?
Right, so we're putting that report together that we talked about. I think it's still up on the screen. So that's the report that's going to describe the methodology and use those example case studies as a way to understand how to apply the methodology.
Okay,
yeah,
great.
I should say it's certainly not a template yet. A lot of these are the hypotheses have to be built. We're hoping to do more case studies. When you have some critical mass, we think there might be some templates for photovoltaic analysis or for advanced HVAC, but until we've done more case studies and built up a repository of benefits, it'll be a little hard to put forward a template that other people could use. But certainly the case studies will give you the actual calculations and assumptions.
Mm-hmm. And we'll definitely be documenting those assumptions in that report, and not only the specific data sources, but also recommendations on, where to, get data. But Vivian is exactly right. We both work closely, with, the engineers and architects that worked on these projects in order to identify the systems that we were looking at and to assess their benefits and their values.
Okay, there are a couple different questions here about estimating. One of them is CII pursuing quantification standards or guidelines on the human capital component. The numbers could be a source of dispute or debate. He says, but clearly looking at all three does improve the numbers if you accept the assumptions and boundary conditions. Another question related to that is, how do you protect against overweighting human capital benefits? Are there overlapping human benefits that could potentially be counted multiple times?
Right. No, I think those.
Go ahead.
Okay.
Go ahead, Robert.
I mean, these are issues that, Vivian and I have struggled with for a long time. So, these are not unexpected questions, but, likewise, there's incredibly large body of knowledge that has looked at this for over 100 years, and how the effects of environment on the workforce, and how that can improve, whether it's temperature, humidity, lighting, all of those in either controlled studies or in field studies have shown benefits. So, air quality, indoor air quality, we know that there's a significant body of knowledge. The question is how much of that to apply, right, as a future benefit, and how much of that is realizable in an individual project. You can say in general, this project is slightly different than, the project that I'm looking at, or anything like that. But I think in the end, there's a consensus building, and a consensus body of knowledge that does show that those benefits are real. So they are, in some ways, more generally less accepted by the industry, but I would argue that those are definitely real and should be considered.
Let me jump in quickly. I know we're running out of time. Just to make that point, in some cases, the third bottom line is the most debatable. But if you're looking at 20-year paybacks or 15-year paybacks at the first and the second bottom line, the question is, certainly for these federal facilities and for headquarter facilities, I mean, most of the buildings plan to be in business for way more than 20 years. So ultimately, it may just tip the scales to let the first bottom line, which is very rarely considered in first cost decision making, it lets it rule. So people say, well, look, it makes sense in 20 years, we should do it. When it gets to the third bottom line, there are some areas where there's really hard numbers. Attraction, retention, I noticed one of the questions was asking about attraction, retention. When we get to the hospital study, Shands Hospital, nurse turnover is a huge cost for an organization. And if the physical environment is a positive player in keeping nurses dedicated to staying with you, you can start to really justify a far better building. So I think that is one of the ones where there's very little debate. Having said that, we need to build those case studies to show it.
Okay, unfortunately, that's all the time we have for today. We'll take a look at these questions, and we might post some of the answers in the blog website as well, because there are some very good questions. Thank you very much for joining us today. We appreciate your time, and we hope that you found the webinar useful. I'd like to thank Robert and Vivian very much for your informative presentation. Stay safe, and we'll see you next time.
Thank you.